Hello viewers, welcome to my video as I'll be covering the rest of the questions, which is question 8 to 12 of IEB November 2021 paper 1. Let's get into it. So now let's start with question 8. So question 8 reads, the first two terms of an arithmetic sequence are log of this and log of that. If the common difference is 1, then what is the value of x? Now what that means is that create an equation involving x and solve for it. But then we are given that the common difference of the sequence is 1. That is where you are going to generate your equation. That means we have log 3 of x minus log 3 of x minus 5 is equals to 1. And then using our laws of logarithms, we can get a single term, which is log 3 of x over x minus 5 equals to 1. Why did we implement this law? Is because our target is to eliminate the logs. Is there any law that you know that can also help you eliminate the laws of logarithm, the log? You will say, if you say 3 to the power of 1, the log can disappear by doing that. So that means if we are going to say x over x minus 5 is equals 3 to the power of 1, it is just 3. And 3 divided by 1 is the same thing. And at this point, we can cross multiply. And then 3 times x, it is 3x. 3 times minus 5, that is minus 15. And x times 1, that is just x. And we need to have these common terms on the same side. So I'm going to throw this x to this side, meaning 3x minus x, that is 2x. Minus 15 to the other side. If we throw it to the other side, it will be plus 15. To solve for x, we will divide by 2. And then we divide by 2, meaning x is equals to 7,5. So that is what we are supposed to get at this point. We are done. Now let's go to B. B, we are saying that a converging geometric series. Immediately you hear that, stop and write what you can deduce from there. I can deduce that whenever I have a geometric series and it is converging, the ratio should be between minus 1 and 1. That is the theory that you should remember. So let me just highlight it from the formula sheet. This is the concept. Now, such that the second term is minus 24. This is the general term for the geometric series, meaning that for the second term, you need to replace where n is equals to 2 to get the second term. To get the third and the fourth term, you need to replace n with 3 and you replace n with 4. So that is what you just need to do. Now, the question is saying determine the common ratio. So what that means is that solve for r. That's what that means only. That is the interpretation. Now, to solve for r, we need to create an equation involving r, or equations involving r. That is the thing. Now, from the first statement, we are given that the second term is minus 24. That means after you've replaced n with 2, you are going to get a r as minus 24. That will become your first equation. And then the third and the fourth terms, which means you are going to say a r squared plus a r cubed is equals to minus 18. That is the second term, right? And then now, what is our task at this point? Our goal is to solve for r. So our task at this point is to eliminate a. That is our task. And we eliminate a by making it subject of the formula. That is what you need to remember. Now, a is going to be minus 24 over r, that will be 3. Now, we are going to substitute equation 3 into equation 2, meaning that where there is a, you are going to replace with the right hand side of equation 3. Let's do that. Meaning we are going to be having minus 24 over r times r squared plus minus 24 over r times r cubed is equals to minus 18. This and this will cancel. We will be left with minus 24r minus 24r squared is equals to minus 18. This is just applying the laws of indices, right? And then here I can bring this to this side so that I can have the complete form of a quadratic equation. Now I like to start with the term with r squared, so that is minus 24r squared minus 24r plus 18 is equals to 0. Now before I factorize this, well, that is a 2 for solving quadratic equation, I need to reduce it to its simplified form that is easier to deal with. I'm going to divide everything by 6. I'm going to divide by minus 6. It will make it more flexible. So divided by minus 6, we are going to get 4r squared plus 4r minus 3 equals to 0. Now if we multiply, we use like your trick for factorizing, we are going to get minus 12. So we are going to get 4, bring down the 4r squared, and then we split this one to plus 6r minus 2r with that technique that you know, minus 3 equals to 0. We'll factor out 2r for the first two terms, meaning you will get 2r plus 3, and then here there's nothing that is common, so we'll factor out both. There's a minus, so you put a minus and then you put a 1. So that is what that is common between those two. When you do that, you are going to say minus 2 divided by minus 1, that will be 2r, minus 3 divided by minus 1, that is plus 3, equals to 0. But then 2r plus 3 and 2r plus 3 is common, so we are going to factor it out. So that means it will be 2r plus 3, 2r minus 1 equals to 0. And then either this is equal, for this equation to be true, it means either this should be equal to 0 or this should be equal to 0, since we are multiplying them together. Now r is going to be, if we throw the 3 to the other side, it will be minus 3, and then if we divide by 2, that is 8. Or r is equals to, if we throw 1 to the other side, that is a 1. If we divide by 2, that will be a half. But are we done? Not yet, because we want r to be minus 1 and 1. So since the series is converging, our final solution for r is going to be a half. So we are done with this part. And then let's go to the next one. You are the manager of a large sports stadium. A soccer tournament is held at the stadium where one match is played each day for 12 consecutive days, right? The following rules and regulations have been given to you as the manager. At the first game, a maximum of 25,000 spectators are allowed. So let's try to put it on the down. So on the first day, 25,000 spectators are allowed. Now what happens at time 2? For each subsequent game, the number of spectators can increase by a constant amount. But do we know it? We don't know it. So let's give it any random name. So let's say the difference, so we will call it D. So that we're going to say for the next game, it's going to increase by D. Or we could have said by X or any letter. So we are going to say 25,000 plus that number that we don't know. And then the third game, each game is still going to continue increasing by a constant amount, meaning the next game is going to increase by D again. So we're going to say D plus D, it will be 2D now. Now it will be 25,000 plus 2D. And then we continue like that until the last game, which is happening after 12 consecutive days. So which is 12 here. Now, meaning we have 12 25,000 plus what? If you look carefully, when there is a 3 here, here there will be a 2, meaning that 3 minus 1, that is 2. When there is a 2 here, 2 minus 1, meaning the coefficient of D is 1. So for us to get the coefficient of D, we just have to say 12 minus 1, that is 11. Now, what is happening? It's increasing by a constant amount so that the last game can have 58,000 spectators. So the last game is going to be having 58,000 spectators. Assume that the maximum number of spectators attends each match, meaning that 25 is fixed for each match, right? Determine the increase in the number of spectators between any 2 consecutive days. If you find the difference between 2 consecutive days, that is the increase. So if you say this minus this, the increase will be D. If you say the next like 3 days 3 day minus the number of people that arrived at day 2, you also get a D. So what this question is demanding you, it is saying solve for the unknown. So for the unknown, that is D in our case. We could have said X, we could have said anything. Now to solve for D, you can either create an equation involving D, or there could be equations involving D, and we will solve for that D. Now, what do we have? We have that 58,000 should be the maximum, right? That the spectators should be like the maximum spectators that the stadium should have after 12 consecutive days, and it should be the same to the general equation that we have constructed here, right? Now to solve for D, we can throw this to the other side so that we can group common things together. Now that will be 8 minus 5, that is 3. 5 minus 2, that is 3 again, so that is 33,000 there. And then 11D, we divide by 11, we divide by 11. So 33 divided by 11, that is 3. So that means D is equal to 3,000. So that is the amount that we are increasing for each game. Now, if a spectator pays 25 rand for for a ticket each day, not for those 12 days, for each day, then what is the total amount of income that can be generated from the ticket sales? Remember, these tickets are going to be sold for the next 12 days. And for those 12 days, we'll be receiving people. So to get the total amount of income, we need to find how many people attended for those 12 days, multiplied by how much each person is supposed to pay. So first of all, we need to get the total number of people. So the total number of people that attended over the 12 days is going to be equal to what? It is going to be the sum over the 12 days, right? And then we know that whenever we have a constant difference increasing, it means we have an arithmetic sequence. And the formula for an arithmetic sequence, it is this one, right? But then in place of n, we are going to replace with 12 to represent for 12 days. Meaning we get the total number of people for those 12 days. Meaning n is 12, we replace with 12, we divide by 2, we open the bracket, 2 times a. A is the first term of the sequence, which is 25,000. And then plus n minus 1 is 12 minus 1, that is 11. And then times D is the one that we solved, the D, which is 3,000, the common difference. And then let's see what we get when we bring our calculator. So let me just reset this calculator. Now we have 12 divided by 2 multiplied by 2 times 25,000 plus 11 times 3,000. That is 498,000 people. Now to get the total income, it is going to be 498,000 times 25 rand per ticket. So multiply by 25. That is 12,450,000. That is what we have there. Now let's go to the next question, which is question 9 now. So for question 9, it is reading: a sports scientist is looking at ways to throw a heavy object further. The diagram below shows 2 throws and models them on the parabola. The first throw starts at O and it reaches a maximum height and it lands at M. The second throw starts at O again, reaches a maximum height of point A and then lands at M. Now, the second throw, we have more information because we know that it reaches the highest point at 4.2. And we have additional information that if the second throw is 2 meters further than the first throw, then what are the coordinates of H? Let's interpret this. 2 meters further. It means that M and N, they are 2 meters apart, right? Now, we know information about the second throw because it has a turning point, right? And what else do we know? We know that that movement is of a parabola. What theory do we know that combines a turning point and a parabola, right? We know that that turning point can be found using either completing the square. If we had an original function, here there is no function that has been defined for us, meaning completing the square would not be, it would have been used to derive, but in this case, it will not be useful information for now. The second thing is, you could have used another method of saying your x is minus b over 2a, that's where your turning point is, and your y value is going to be f of minus b over 2a. But in this case as well, again, it's not useful because we are not given the function. So you cannot identify your b, you cannot even identify your a. It's also useless. What else do you know? You also need to know now that your turning point is going to occur, or it is at the midpoint of the parabola. It is symmetrical. What does that mean? It means it divides that parabola into 2 equal parts. That is the theory that we need. Why? Because we would know that from this point to this point, it will be 4 meters. And from this point going to the end, it will also be another 4 meters. Now, that means that this n is going to be 8 meters. That is what we can deduce. That now, what can we deduce about m? M, the relationship between m and n is that n is 2 meters further ahead of m. So that means n is going to be 6 meters. We just need to find the difference between 8 and 2. Now, we have everything that we have deduced from what we know, the theory of that. Now, we start from what we know going to what we don't have. So we have used that turning point. Let's also try to use the turning point that we don't even have the things now. But for that turning point, we also now have the point, this one, which is 6, 0, meaning that we know that from here to here, it's what? It's 6 meters. But then since we know that H is a turning point, it means it is supposed to symmetrically divide the parabola, meaning that this is going to be 3 meters, and also this is going to be 3 meters again. And what happens is that it means that our H coordinate is going to be 3, some maybe y value. So that y value, maybe I can call it k. Some k value, we don't even know it. Right? And the question is asking, what are the coordinates of H? So what the coordinates of H, you need to find the k value. So what is our goal at this point, given all the information? Our task is to solve for k. Maybe if you wanted to do that, maybe you can just say, let the y coordinate of H be k, right? And then already with the x coordinate of k, here maybe you can say the x coordinate of H is 3. That is what we have. And how you got your 3, it is, you said 6 divided by 2 because of the symmetry. Now you are trying to give your solution as detailed as possible. Now, but then here, remember, I was saying the task, I don't think it's necessary, because just what's happening, what should be going in your head. It's not really necessary. Now, how do we solve for this k? We would need to construct a function. Once we construct our function, we will substitute these 3 into the function. Now, what information do we have about this function that we're interested on? Because H is sitting on that parabola. So what information do we have about that parabola H? We know that it has coordinates 0, 0. It has also coordinates 6, 0. And also it has coordinates 4, 2. Meaning we have 3 points that we have at hand. And we need to make a choice with all those 3 points. Which ones are we going to use to create a function of that parabola? Now you need to understand that to create a function of a parabola, it is easier to do that when you are given where the parabola intersects with the x-axis. So it means it is to our advantage to choose 0, 0 and 6, 0, because those are related by the they are related because of the x-axis. If you choose that, those other one, there will maybe be some complications there, but for now it is of good reasoning to choose 0, 0 and 6, 0. Why would you do that? Because we would construct our f of x as equal to what? As we have a, it's an unknown, because remember the general structure of a quadratic formula, go for quadratic equation, it's a x squared plus bx plus c. Always when we are solving these ones, we are going to always factor out a. That is the key. So with the same thing, we will write our a here. And when we do our completing the square and whatsoever, what we do, all those things, the idea is to solve for the equations for the roots of x. And you get that those x are found when there is 0 and when there is 6. Those are the roots that we are going to find. So it means we are going to say x minus 0, x minus 6. Those are going to be our roots. Was either going to say this is equals to 0 or this is equals to 0 to extract your x equals to 0 or x equals to 6. Now this one is going to be ax, and then x minus 6 is our function of the parabola, but not completely. We will also need to use another point, because we have used these 2 points for now. Let us also use the other point, which is 4, 2 to finalize, because you need to use all the information that we have. It means that this is the x value, this is the y value, and this is supposed to be the y value. The f of x is the y value, which is 2, which is equals to a, the x value is 4, and then 4 minus 6, and then a is equals to, so 4 minus 6 is minus 2, 4 times minus 2 it's minus 8, 2, wait, I'm just trying to check. Okay, I said 4 minus 6 is minus 2, yes. Minus 2 times 4 is minus 8. Minus 2 divided by minus 8 is minus 1 over 4. Yes. I'm still okay in the right track for now. And then now it means that our f of x is equal to minus 1 over 4 x minus 6. But the goal was to solve for what? Was to solve for k. So we get k when we plug in the 3 into the function that we have created. So it means that k is going to be equal to minus 1 over 4 of 3, and then 3 minus 6. So let's check what we get there. So what we get, we say minus 1 over times 3 times, so 3 minus 6 is minus 3. So the coordinate is going to be 9 over 4. 9 over 4 is the same thing as 2,25. So the coordinate of h is what? So the x coordinate we said is 3, and k is the y coordinate, so it's 2,25. Then we are done. So that is how we were supposed to solve question 9. And then now let's go to question B. Question B, it reads, a quadratic function f of x is that. Okay, cool. Now we are given this information, and the question is asking, draw a rough sketch of the graph of f of x and clearly label turning point clearly. Let's try to deduce each line by line what it means. This line, it means that the quadratic function, it is symmetric around 6, because they are saying if you say 6 minus p, it will be the same thing as 6 plus p. So that means that this quadratic graph, it is symmetrical around 6. That's what it means. We are trying to interpret. And we need to know the theory. Whenever you hear something linked to the symmetry and whatsoever, you need to know that that symmetry occurs when we have minus b over 2a, right? So we are simply, what we are saying, minus b over 2a, it's 6. That is what we are saying. That's what we can deduce from the first line. And meaning the second line, we are saying that the function, when we put in our 6, we should get in 2 as the output. That is what's happening. Cool. Now let's go to the next one. So let's come up, because we need a general structure of the graph, because a graph, this graph, we don't know our a, if it is greater than 0 or less than 0. If a is greater than 0, our general structure of the graph is like this. If a is less than 0, our structure of the graph is like that, right? Now, we are told that the graph is symmetrical around 6, which is 6 here. We can put a 6 here, and also we can put a 6 here. And then the corresponding y coordinate is 2. So 2 is here, 2 is here, right? And then now, either the graph will be pointing up, meaning it will be coming up, or it will be coming down. That is the idea. Now, let's look at the next information. But we are given now that b squared is less than 4ac. Now, let's rewrite it. This is the same thing as b squared minus 4ac, which is less than 0. Now, if we go to our quadratic formula, you get to see that b squared minus 4ac, it is inside the square root. Whenever now we are putting a negative number into the square root, we are generating an imaginary number, meaning that there is no real number that can exist there. The graph is going to hang in the air. Now, between these two choices, when is the graph going to hang in the air? This one is the passing test, because this one will come down and intersect with the real numbers there. But here we don't want even to intersect with the real numbers. We want it to go up. So we have a structure. Now that means that we just only need a sketch. So for the sketch, this is the x, this is the y. We need the 6 here, we need the 2 here. This is symmetrical around this point, and then it can come like this. And I think for the sketch, it should be good enough, because any point above 2, either it could be 7, it could be 9, it could be anything. But further than that, with all this given information, I don't think we can deduce anything further than that. That is it that we have there. And then let's go to question 10. 2 more to go. In the diagram below, we are given that f of x is a cubic function, g of x is a linear function, f and g intersect at a, cool. If h of x is tangent at a, then calculate the coordinates of b. The x-intercept of h. So h is the function, right? So we are required to calculate the x-intercept of h. And the x-intercept of h is obtained when y is equals to 0. That is from the theory. Okay, cool. And then the question is asking me about the coordinates of b. Now, what information do I have that is related to b? I have that b, it is sitting on a line given like being h, right? Meaning that if I can identify, so the task is, if I can identify the equation of the line h, if I can find the equation of a line h, I can be able to get the b coordinate, because my y value is equal to 0. Then I get my x coordinate. So my task at this point is to create the equation of the line h. That is the task that I have. Okay, cool. Now, with that task of creating the equation of that line h, what information do I have about h? I have that h is a tangent at a. And what does that mean? So now maybe what we can say we need to interpret this line. For now, we are saying h is a tangent at a. For now, let us figure out what a is. So we need to find the coordinates of a, and then we'll come back to interpret that line. So let us find the coordinates of a. And how do we find the coordinates of a? The information involving a, it is the intersection of the graph G and the graph f of x. So that means we need to set it equal to each other first. Let's do that. We're going to say f of x is equals to g of x, which is x cubed minus 5x squared plus 3x plus 9 should be equal to 3x plus 9. Then if we throw everything to the same side, this and this will cancel, this and this will cancel because of the sign of the signs, right? And then here we are going to factor out x squared because it's common. We are being left with x minus 5 being equal to 0 because everything has been thrown to one side. So either x is equals to 0 or x is equals to 5. This is where 0 is and this is where 5 is. Because we want 5 to be the intersection point for this graph or this point. So for the a coordinate, it means that the x is that we really need is 5. And then if we substitute in the graph of G, if we replace with 5, we're going to say 3 times 5, that is 15. 15 plus 9, that is 24. So the coordinates of A is 5 and 24. Now we have our coordinates of 5 and 24. Now let's try to interpret what this statement was saying. It is saying if h of x is a tangent at A, right? What that means is that a tangent is related to the what? To the function that it is touching. So the function that it is touching, it is the function of f. And it becomes, at that point, we can get a gradient. So when h of x is a tangent at A, it means we can get a gradient. And how do we get the gradient? We are going to get a gradient by differentiating the line it is touching, which is, if we say f prime of x, right, and we substitute the x value of 5, right, we will get the gradient, right, the gradient of line H, right? That is from the theory. Now, when you have the gradient of line H and you have a point, can you now create equation H? Because that is our task. Yes, we can create our thing, because let's go to the formula. This is the general formula for creating equation of a line, meaning that we are saying we need to identify y1 and x1, which is just the point that we already have for now. So our 5, it is x1, our y1 is 24. So that is the thing that you just need to do. You are going to say y minus y1, it is 24, this one, is equals to m is the gradient. So to get the gradient, we said we have to find the derivative of f of x, and then we'll put in the value of 5 inside to get the gradient of h, right, is equal to the gradient of m and then x minus 5, and then m is equal to the derivative of 5 when you are plugging in, because we said the gradient is the m, right? So m is the same thing as when you get the derivative of x, and then you plug in. And then here we can say that not f prime of x is going to be, so let's differentiate f prime of x, f of x, because f of x is the left hand side, which is this one. So we will drop down the 3, we get 3x squared. We drop down the 2, it will be minus 10x. We will differentiate that 3x, it will be plus 3. And then we are going to say m is equals to f prime of 5, which is equals to 3, 5 squared minus 10, 5 plus 3. Now let's just bring the calculator and let's get what the solution is going to be, which is 3 5 squared minus 10 5 plus 3, that is 28. So our gradient is 28. Now we are only supposed to say our y is equals to 28 times x is going to be what? Is going to be 28x. 28 minus 5 is going to be, so let's also just bring the calculator and finish up. We are saying 28 times minus 5 is going to be minus 140. And then minus 140, because remember, we have simplified the right hand side so far. We will need to throw this to the other side, meaning we need plus 24. So the y is equals to minus 140 plus 24, that is minus 116. So it is 28x minus 116. So this y that I've got, it is the equation of the line H. Now when we have the equation of the line H, we are told that the x-intercept is when y equals to 0. So we replace where y is equals to 0. We're going to say 0 is equals to 28x. If we throw this to that other side, it will become 116 is equals to 28x. So therefore x is equals to what? Is equals to 116 divided by 28, which is 29 over 7. So the coordinate of H is going to be, the x value is 29 over 7 and the y value is 0. Then you are done. And then let's go to the next one. The next one is saying the following information is given. The derivative of f the derivative of f is this one, or f prime of x is that one. So for now, let us simplify that. For now, we'll get x squared plus 2x plus 1 minus 4. So that is, we get x squared plus 2x minus 3. Okay, and then f of x has one real solution. Remember, we have f prime of x and f of x. Before we do whatever, now we need to try and think, what is this? This is a quadratic expression, right? Or a quadratic function, right? And what is the relationship between original function and the function that we have derived? It is just that the original one will be 1 power higher, meaning if the derivative is x cubed for the polynomial, the higher the f of x, the original one, will be a cubic graph. That is the relationship. And is there anything we need so far? So let's leave like that. So that is what we can deduce. We are trying to see whatever that we can do. And then the question now is asking, for what values of x is f of x increasing? Now, it means now we need to solve for the critical values of f prime of x, because remember, if we know about the derivative of f of x, or if we know the f prime of x, we will know the behavior of f of x. I'll explain why. So for now, what we are going to do, we are going to find the critical values of f prime of x, and then this is just was minus 3 times 1 is minus 3, and then the factors that can form that, it will be x plus 3, x minus 1, and then equals to 0. So x is equal to minus 3 or x is equals to 1. So those are the critical values. And then now, what is the general sketch for this graph? The general sketch for this graph, the coefficient of x squared is 1. So when we have a quadratic graph, because remember the form is x squared plus bx plus c. If a is less than 0, the graph will be like this. If a is greater than 0, the graph will be like this. So in our case, our a is 1. So it means we expect our graph to be like that, right? So the general sketch of the graph, it is like this. And then this point is minus 3. This point is 1. And how can we relate? So this graph is the graph for f prime of x. And this is the x-axis that maybe we can just leave it. Now, whenever we are above the x-axis, the f of x is going to increase. So when you're above the f of the x-axis for f prime of x, f of x will be increasing. So it means now that this is the region that we are interested in. This is the region that we are interested in. So usually this question is interpreted, I can interpret it as x plus 3, x minus 1 greater than 0. So usually they could ask something like that, but that is the moment for them to ask you that. Now, it means the x values, it is when x is less than minus 3 or x is greater than 1. If you want it in set notation, or less than or equal to, sorry. So here, greater than or equal to. Here, if you wanted, you could have said minus infinity, minus 3, union 1, infinity. So it depends which one you like, but usually, in my case, I prefer the first one. It's less confusing. Now I'm done with the first part. Now the next one, use the information above of f of x on the set of x's below. Label the x values of your turning point and the x value of the point of inflection. You need the theory that connects the graph of f of x and its derivative. Now, just putting the information, we have extracted something about minus 3. So let us label minus 3. There has to be related, and there is a 1. They have to be related. And then now, what is our point? Our point is that our minus 3 and 1, these are our critical values. So those values for the derivative of f prime of x, theoretically they should be our turning points. So that is the theory that we need to remember. Those will be our turning points. Now we are not yet done. We need the general structure of the graph. Because we say the graph that we need to sketch here is supposed to be a cubic graph. So the standard structure of the cubic graph, what is the standard structure of the cubic graph? We have f of x is equals to, maybe let's say, ax cubed plus bx squared plus cx plus d. This a as well is going to give us the structure of the graph. If a is less than 0 and if a is greater than 0, we also have its form. So when a is greater than 0, we expect a structure of a graph like this. That is what you should remember. It starts by rising and comes down. If a is less than 0, it will be the opposite of this one, whereby it starts by, how can I put it? It starts by coming down and then it ends up like that. That is the structure of the graph that we need to remember. Now we need to identify, so which form is A taking now? Because we have the coefficient of x squared, it's a 1. It means that this A is positive on the what? On the cubic, on the quadratic graph. It means that on the original one that we would have differentiated, we would have been positive. So the conclusion is that A should be greater than 0. So that is the idea. Because if there were a negative here, if there was a negative there, we are going to conclude that our A was going to be less than 0 and the form was going to be this one, not that one. So our idea, we know that the form that we need is this one. And then what other information we are given? That f of x is one negative resolution, meaning that this part is the one that will be on the negative side, that is supposed to intersect. So at one point we are going to intersect a negative solution. That's what it means. But then remember, we said -3 is a turning point, so it will come and do a turning point there. So this point we can say maybe it's -3 comma y, and then it will come down to the other turning point. Now remember, the question, it says it has one real solution, meaning for the rest it will be hanging in the air. That is the thing that you need to remember. So this is the structure, and this point is 1 comma y, and then we don't know the y coordinate. So for the y coordinate, we're going to say x 0 comma y, so because we don't know the original function graph. But then we are not yet done, because it requested the x values of the turning points. We have done that. This is the turning point, this is the turning point, and the x value of the inflection. We have not done the inflection. But when do we get the inflection? We get the inflection when the second derivative of x is equals to 0. Now let's get that. So f derivative of x is equals to what? So let's go and derive this one, because this one was our f prime of x. So if we differentiate it again, we'll get the second derivative, meaning it will be 2x plus 2. And we want 2x plus 2 to be equal to 0. It means that 2x is equals to -2. So we divide by 2, we divide by 2, x is equals to -1. So the inflection point is going to be happening here, that is -1. So it will be happening at -1 comma the y value, because we don't have the original graph of the function. It's only the examiners that know the exact form of the graph, this one. Now let's go to question 11. Now for question 11, we are almost done. 2 more questions, right? Now a farmer draws a rough sketch of 2 adjacent fields he needs to fence. Field A is a square with width x. Now let's interpret that. Field A is a square of width x. What does that mean? It means that all the sides are of length x, but here we only have been labeled x. So it is your duty to know that this will also be x. Also this other side will be x, this n arrow will be x, and also PQ will be x. Like you can see with your eye, you can be able to see that. And then this other side, we said it's x, this other side will be y. We are putting everything that we have before we solve the problem. Field B is a rectangular with width y. Okay, cool, nothing I can deduce there. And then that's why they put a square in bold, because they knew that maybe one could get confused there. Area of field A, we need area of field A plus area of field B is equal to 1,000 unit squared. That is the given information. So we need to remember that. NR is the only fence that is shared by both field A and B. Why that information is important, you will find out. We don't know yet for now, we need to find out why they gave us that statement. Find y in terms of x. Now, which statement are we given? We have the third line. The third line is that the area of field A. What is field A? That is a square. And what is the area of a square? The area of a square is x times x, so that is x squared. Plus, area of field B is x times y, so that is xy. Should be 1000 units squared. So the idea is to find y in terms of x. So we are going to throw this to the other side. So we have xy is equals to 1000 minus x squared. So we divide by x, we divide everything by x. So y is equals to 1000 over x minus x squared divided by x. It is just x. So we are done with this part. Now let's go to the next point. Calculate the value of x so that the minimum amount of fencing is used. So now let's start by writing the amount of fencing required to cover this area is equal to what? This is just perimeter. That is the what you want to cover. So what you get to see that you have how many areas do you have? You have how many x's do you have? You have 1, 2, 3, 4, 5. The reason why they said this is NR is the only fence shade, so that you don't double count it when you are doing. Maybe what you could have done, you could have said, how for the field A I have 1, 2, 3, 4. You note I have 4x for field A, and then for field B I have 1, 2. So you're going to say plus 2x. That is where you're going to be lost. So the only fence, meaning you don't have to double count. You have to say 1, 2, 3, 4, 5. So I have 5 x's. So the amount of fencing required, I need 5x, right? And then 5x unit size, and then plus how many y's do I have? It is just this and that. That is 2y. But then the question is about the minimum. And when it's minimum, that is an optimization problem. And when you are faced with an optimization problem, you want to find the best outcome. And the best outcome, usually, we need to find the first derivative. Is going to guide us in the process. And for us to find the derivative of these two variables, it's not something that we can do in metric. So it means we need to create one variable, meaning we need to destroy either x or y. But already we are given a hint that make y subject of the formula. Whenever they say express something, it means it needs to be destroyed. It's a hint in quotation marks. Why? Now let's create the function. Maybe let's say the amount of fencing, maybe let's call it f of x. It's now going to be f of x plus 2 open bracket, your y is 1000 over x minus x, and that is going to be 5x 2 times minus 2, that is what? Minus 2x. So 5x minus 2x, that is 3x, plus this time that it will be 2000 over x. Now we need to find the derivative of that, which is f prime of x is going to be 3 here. And then remember that 1 over x is the same thing as x to the power of minus 1. So we apply the rule of dropping down the minus, and then we will subtract a minus 1. Meaning we have 2000 x to the power of minus 2. And it is the same thing as 3 minus 2000 over x squared. You need to remember a laws of indices. And we need to set it equal to 0. Right? Now we can throw this to the other side. So we have 3 is equals to 2000 divided by x squared divided, this is the same thing as 3 over 1. We can cross multiply. So we have 3x squared is equals to 2000 divided by 3 divided by 3. X is equals to the square root of 2000 divided by 3. So x is equals to what? Let's bring the calculator. X is equals to the square root of 2000 divided by 3. That is 25.82. So we have 25.82 units. So that is the value of x, so that we can achieve the minimum amount of fencing to use. So we are done with that problem. And then let's go to the last problem, which is question 12. So for question 12, we are given that 5 cards are given below. The 5 cards given below are used by players in a game to create 5-digit codes. A few examples of the 5-digit codes can be created with the cards above are the blah 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 blah, that is that. But then there's a restriction, that is no repetition is allowed. Now, how many unique digits can be created, right? Now, if I were to say pick any card there, how many chances do you, how many ways can you pick any card? How many possible ways can you? So there's 5 ways. Either you can pick 1, or you can pick 2, or you can pick 3. So the first attempt, if I say pick any card, think of them as card. You pick, maybe you have a chance of picking 5 ways of doing that. And then now, when you have, let's say you have picked this one, and I say pick another one, how many are you left now with? You are left with 4. So since these are independent events, you now have 4. You have, let's say you have chosen 2, and I say pick another one. You are now left with 3. You are left with 2. You are left with 1. So in other words, that is 5 factorial. And 5 factorial is what? Let's just get it. 5 factorial, that is 120. So 5 factorial is 120. And then the second point is how many unique 5-digit codes starting with a number can be created. Now we have another restriction now. So the restriction that we have now, we are told that we have 1, 2, 3, 4, 5. This point we are saying how many unique 5-digit codes starting with a number. So this should link to a number. So that is a restriction. So this position is fixed. These other positions, they are flexible. You're trying to think, right? And then now, so how many ways can that happen? Now we need to calculate. The first position is only fixed to a number. How many numbers do we have? We have 1, 2, 3. So there's 3 possible ways. You could have chosen maybe 3, or you could have chosen 2, or you could have chosen 1. So there are 3 possible ways, because they are fixed. That position is fixed. So we will take 3 possible ways that can happen, multiplied by the remaining ones. We have 4 positions, but those 4 positions, they are flexible. So since they are flexible, you want to form unique 4 codes there. So to form 4 unique 4 codes, that will be 4 factorial. Was it's 1, 2, 3, 4. 4 flexible things. So that's 4 factorial. That's it. And then let's go to the third question. The third question is, what is the probability that 2 letters will never be next to each other in the code? Now we need to go back to our question. what is the probability that two letters will never be next to each other in a code? What does that even mean? You are trying to think. It means, for example, I'm going to represent the numbers with the letter N and the letters with the letter L. It means if, let's say, for example, I have started with a letter, I'm not allowed to put another L or another letter. I'm only allowed to put an N there, a number, and maybe another number, another letter. Or we could have said, if we started with that letter, obviously we're not allowed to follow with a letter. We're allowed to put a number, right? And then maybe you could have put another number, and then you put a letter, and then you put a number. And then, so now if we try to check, now there's another thing that I want you to see. If you want to think about all possible ways that could happen, you could go crazy. It's very hard to imagine. But here's the key hint. We are dealing with probability. And the nicest thing about probability, we know that the probability is only restricted to 1, right? Now, since going directly is complicated in this case, is there any way I can go indirect, right? So the indirect way is the one that we need, because we are going to say the probability that two letters will never be next to each other is equal to 1 minus the probability. So if they will never be next to each other, what will they be? The probability now that the two letters will be to each, like, will be together. That is another, that, so minus the probability that the two letters will be together. That is the only thing. But the other thing that we just need to take note, the position of those two letters being together is not fixed, it's flexible. So let's put our drawing first. Because usually I try to reason with these, like these animations, I try to give, is it fixed, is it flexible, and all that. So I've been told that the letters should be fixed, so they form what I call a block. And that block is flexible, because we are not saying that those letters should be in the first position or should be in the second position. That block is going to be fixed. So that block is for letters being next to each other. And then we have individual numbers. Those numbers, they are flexible. They are flexible. Now, the first part, we need to take into account that we have formed a block, right? Forming a block, what does that mean? It means we have two letters. Either you can start with A first and then you form B second, or you start with B first and then you form with A second. So how many ways can we form that block? So first of all, you need to take into account about forming that block. There are two ways of forming that. So that is 2 times. That block is going to be flexible, right? That block, we can treat it as one thing. And also we have 3 other flexible items. So how many flexible things do we have altogether? It is 4 of them. And those can be formed by making them 4 factorial. So that will be 2 times 4 factorial. So that is how many ways the letters can be together. Meaning that this is going to be 1 minus 2 times 4 factorial divided by all the possibilities that can ever exist. All the possibilities that can ever exist is 5 factorial. So which is 5 factorial. And then what should be our solution? So remember, when you have flexibility, you take 4 factorial or whatsoever. There, like the same thing when we said 5 factorial, we had 1, 2, 3, 4, 5 positions, and they were flexible. You can arrange them anyhow. The only restriction is that no repetition. So you will say 5 factorial. So that is why I did what I did there. Now, let me bring the calculator and let's see what we get. So what we get is 1 minus 2 times 4 factorial divided by 5 factorial. That is 0.6. So that is the probability that two letters will never be next to each other when forming a chord. So we are done with that problem. And then we go to the last question of the paper. And yes, we are done. Now, we are saying that you have 6-sided die that you use to create a geometric series by randomly throwing a die, or by throwing the die. The one dice is red, the one dice is blue, and the third dice is green. Now, here is the catch. Here is the catch. Here is the catch. Here is the catch. You are going to, so let's finish. The number of the red dice represents the value of the first term of in the series. So remember, this is a geometric series. So let's go to the formulas. So whenever you have a geometric series, the first term is given by A. So it means the red dice is responsible for generating A. Right? And let's think about it. Since it's a 6-sided die, if you throw it up, you can get either A could be 1, A can be 2, A can be 3, or A can be up to 6. So that is the possibilities when you throw a red dice, right? And then you take the value of the blue dice and divide it by the value on the green dice to generate the common ratio. Now, let's say this is just an example. What this happens for the for the geometric series that we are forming with this puzzle. Let's say, for example, this is our red dice, this is our blue dice, this is our green. This is a possible outcome that could happen. This is a possibility. You toss your dice in the air, you get a 4. That is possible. Now, it's for the blue dice. You toss the blue dice in the air, you get a 2. You toss again a green dice, you get maybe, let's say, a 6. Right? Now, according to the formula, we need to formulate a series that can, a geometric series. According to this attempt that has happened, we are getting that Tn is equal to A is 4, because it's the A, because they said the first term of the series is A. And then times the ratio is the division of the blue dice by the green. So it will be 2/6 is the ratio, and then raised to the power of n minus 1. So based on this outcome, based on this event, this is the series that can be formed. And we may need to check that here now, this is the other thing. What is the probability that if you sum the series to infinity, it will converge? Let us check this series. Will it converge? This example that I've given, will it converge? Our A is what? Our A is 4. We divide by 1 minus r. 1 minus r is 1/3. So the sum to infinity for this chance that we have created, it's 4 divided by 1 minus 1 over 3. So this possibility, it converges to 6. It does not converge to the number 10. So it means this possibility will not pass to be the number 10. Now, the issue that we have how many possible combinations can be generated. This is one of the combination, right? 4, 2, 6 is one of the combination. We could have generated 1 on the first dice, 1 on the blue dice, 3 on the green dice. We could also have formed another, what? Another geometric series. So how many ways can that happen? So that is the thing that we need to check. There is 6 possible ways we can form pairs from a red dice, but it's independent on the blue throw. So times the blue is going to have also 6 possible ways. So maybe let me now erase there. I was just giving you an example. So there is 6 possible ways of arranging a red dice, and is independent of 6 ways of arranging a blue dice, and is independent of arranging 6 ways of arranging a third dice. So this is equal to total possibilities. And how many of them? We have 6 times 6 times 6, that is 216. So we have 216 possible ways we can generate geometric series, right? But then out of all these 216 ways that we can generate geometric series, there are some that are going to create a series that will converge to a number 10, right? So we need to find how many those combinations, like how many possibilities can we get. Then we'll put them on the numerator, and then we'll divide by all the total possibilities. Now we need to put everything together. From the sum to infinity formula, we said sum to infinity is equals to a over 1 minus r, right? So sum to infinity is 10, we are targeting 10. And then we are saying 10 is equals to a over 1 minus r. At this point, we will cross multiply, meaning we will get 10 times 1 is 10, 10 times r is minus 10, r is equals to a. Now, the idea now is to check on the ratio. So let's make the ratio, because we will just see what's going to happen there. So we're going to throw this to this side, and then we throw a to this side, meaning we have 10 minus a is equals to 10r, and then we divide by 10, we divide by 10. So r is equals to 10 minus a over 10. So what that means, this should be, because remember we said a is the outcome for the red die. So let's go and give meaning to this one. Why did I put it in the ratio form? So that you see that the possibility that we want to generate, but the ratio, it should be the division of the what? The division of the blue and the green dice. And the outcomes should be between 1 to 6. That is the restriction. Now, let's try to think about this situation. Let us say we have got our A. So this is trial and error because we want to try and figure out. So this is our check. When, let's say you have rolled your dice and you get your A as 1. What does that mean? It means that your ratio is supposed to be 10 minus 1. It's 9 over 10. Can 9 over 10 be expressed in terms of all the terms that are from 1 to 6 in any way to form a ratio of 9 over 10? There is no way that can be expressed as this, or you find out what I mean by that. So meaning when A equals to 1, we will fail the test when you want to find a series that will converge to 10. So this one will fail. Now let's check another one. When A is equals to 2, so just to check all those 6 ways. When A is equals to 2, what's going to happen? R is going to be 10 minus 2, that is 8. We have 8 over 10. Can that 8 over 10 be reduced? It can be reduced to 4 over 5. Meaning that this outcome is interesting because we are going to have a 4 on the blue dice and we are going to have a 5 on the green dice. This outcome is guaranteed to converge to 10. So this one passes. Nice. We have one outcome so far. Now let's check another one. When A is equals to 3, it means that R is going to be A minus 3 is 7 over 10. Can 7 over 10 be reduced in any way? No ways. This one will fail. Now, when A is equal to 4, R is going to be equal to what? R is going to be equal to 10 minus 4, that is 6 over 10. Can 6 over 10 be reduced? It can be reduced to what? It can be reduced to 3 over 5. And 3 over 5, they are part of this set. Meaning that either you could have got a blue on the 3 or you could have got a green on the 5. So this one also passes the test. So we have so far one that passes the test and the second one that also that passes the test. We're almost done. So when A is equals to 5, we have R equals to what? So 10 minus 5, it's 5 over 10. And 5 over 10 can be reduced to be 1 over 2. This passes the test. So 1 over 2 passes the test. But we need to be very careful there. Because if you say 1 over 2 multiplied by 2 over 2, what will you get? You will get 2 over 4. Meaning that 2 over 4 also was going to pass the test. Now, if you had said 1 over 2 times 3 over 3, we're going to get 3 over 6. 3 over 6 was also going to pass the test. Meaning here we have 3 possible ways of forming a ratio of a half. There are 3 possible ways of forming a half. Now finally, when A is equals to 6, R is equals to 4 minus 6 is 4 over 10. 4 over 10 can be reduced to 2 over what? 2 over 5. And then if you had tried the technique of saying multiply by 2 over 2, you end up to see that it will be 4 over 10, which will be outside the range. So this one, it can never be created to be like in other case. If you had tried for the others, it would also not have worked. So we have one possible ways. Now, if you check, there is one way this passes, and then this passes 3 times. So it's 3 plus 1 is 4, 5, 6. So there are 6 possible ways of generating a series such that it will sum to an infinity of 10. Now that means that we are going to be having what? We are going to be having the probability of that happening, it's 6 possible ways over the total possible ways, which is 216. And if you put it in your calculator, you are going to get 6 divided by 216, which is 1 over 36. 1 over 36. We are done. Thank you so much for watching, and I think out of this paper, the last question, this question was challenging, I don't want to lie. Thank you so much for watching. All the best with your tests.